Good evening to all.
Good evening, sir.
Good evening, everyone.
Good evening, sir.
Good evening, sir.
Good evening.
Good evening, sir.
Good evening, brother. So we are into the second lecture of this solid state physics part. So yesterday we discussed about the basics of crystal structure and of course about the various symmetries prevailing in the lattice and then how many various lattices are there corresponding to those symmetry operations, and of course about unit cells also. And today we are going to study the basic crystal structures, and first of all the cubic ones and the structure of various ionic solids. Okay. So first of all, simple cubic structure. Simple cubic structure. Now, this is the simple cubic structure that I have shown. Actually, in simple cubic structure, if we try to make the structure, then there are atoms at the corners of the unit cell. So atoms are at the corners like this. And the unit cell of the simple cubic structure, it is primitive in the sense that atoms are present only at the corners. And if we see the contribution of the atoms, then there is one atom per unit cell. In primitive one, there is only one atom per unit cell. And how there is one atom per unit cell, and all these atoms, they are touching each other. That's why I have shown you the actual structure. You can see these are touching each other like this. So if we try to make the front face, and suppose the radius of each atom it is r, then the edge length will be equal to 2r. Is it clear?
Yes, sir.
Now, first of all, number of atoms per unit cell. How many number of atoms are there per unit cell? Now see, there are 8 atoms at the corners, and each corner it is shared by how many cells? How many cells?
1.
Each corner atom is shared by how many cells? Unit cells?
8.
8. So the contribution of each atom at the corner it is 1 by 8, and that's how there is only one atom per unit cell. Yes, I'm making the diagram also. Now, how this atom is being shared by 8 of these? See, so there will be one unit cell below this one, like this. So this one is being shared by 1, 2, then there will be another one to the right of this one. Isn't it? Are you getting what I'm trying to say?
Yes, sir. So, sir, you are saying that each corner is.
Yes, I have taken this as reference. This one. I'm making the diagram. This and I'm making the unit cells so that I can make you visualize how this is being shared by 8 unit cells. So now you can see it is being shared by 4 of these. 1, 2, 3, and 4. And 4 more are there in front of these 4. Then only this will be completely enclosed. Not this reference one. Please check. Okay. Will be there in front of these 4 unit cells. And that's how, therefore, that reference atom is shared by 8 unit cells. Now clear? Is it clear or not?
Yes, sir.
So that's why we have taken 1 by 8 factor, because there were 8 of them, 8 corner atoms, and each corner atom is being shared by 8 unit cells. So there is a contribution of 1 by 8 to 1 unit cell, because we want to calculate the number of atoms in 1 unit cell only. Clear? Now what about edge length? What about edge length? Edge length means side of unit cell. It will be 2r, just as I explained.
Yes,
because both atoms are touching each other. If r is the radius, where r is the radius, r is the radius of each atom. Clear? Now another quantity is packing fraction. Now what is packing fraction? Packing fraction tells us how densely a structure is packed, and in order to find that, what we need to do is we need to calculate the actual volume occupied by the atoms and divide it by the total volume present inside the cell. Okay, so now volume occupied by atoms in the unit cell. Now how many atoms are there in the unit cell?
1.
And we have assumed atoms to be spherical, and radius is r. So it means this volume will be 4 by 3 pi r cube. This is the volume occupied by atoms in the unit cell. When you are placing 8 atoms at the corners, then they are occupying this much volume of the unit cell. Okay. Now what is the total volume available? How you can get the total volume of the unit
Volume of the cube is 2r.
cube, and it should be side cube, na?
Yes,
Right?
sir.
Okay. So volume of unit cell, it is 2r cube, that is 8r cube. Now packing fraction, it is V dash by. V dash means volume occupied by the atoms in the unit cell divided by actual volume of the unit cell, or the volume available. And this is nothing but, and you can see it is pi by 6, which will come out to be 0.5. It means 52% of the space is filled and 48% of space is empty. Can I say this?
Yes, sir.
So it means this simple cubic arrangement, it is not an efficient way of placing the atoms because almost half of the space is empty. Means we are not making the proper use of the space available to us. We could have accommodated more number of atoms. Okay. We could have accommodated more number of atoms. Clear?
Yes.
And in the exam, you have to be careful. They can ask you about the empty space also. Rather than asking you about the packing fraction, they can ask you about the fractional empty space. So that's why I've given you that 48% factor. Or you can also write it as 1 minus pi by 6. This is nothing but 1 minus pi by 6. No? So you have to be careful in the exam. That what has been asked. Is it the packing fraction or means the space occupied or the space empty? Now, what about the coordination number? Coordination number means number of first nearest neighbors. First nearest neighbor means those which are immediate in the vicinity of the particular reference atom. So that is called coordination number. Now, how many atoms are there which are in direct contact with the particular atom?
6.
Yeah, of course. If I take this one as a reference, okay, this one, then you can see one will be here. Of course, this is 1, 2, 3, 4. This one is 5, and to the left of this one is 6. No? Please check. The atoms which have been tick marked by me, they are the first nearest neighbors of this particular atom. Please check. They are 6 in number. No? Clear?
Yes, sir.
So coordination number or the number of first nearest neighbors. 6. And what is the distance? First nearest neighbor distance. Just by looking at the diagram.
1 side.
What is that value? It is
1.
It is 8.
What?
Yes, first nearest neighbor distance, it is equal to 8. Okay, A or 2 are they are the same thing because both are equal. Now, can we get second nearest neighbor number and distance and third nearest neighbor number and distance? So if we have to calculate it just by looking at the diagram, then the things are going to become difficult as we go on finding the next nearest numbers rather than the first one. Okay, because it will be difficult to visualize somewhat as compared to first nearest numbers. Then there is a trick available with us with the help of which we can calculate up to third nearest neighbors very easily, and of course their distances also. And that technique is going to work in all of the cubic structures, whether it is simple cubic, body centered cubic, or face centered cubic, and it will be very useful for you in the exam also. You need not cram these things. Okay. Otherwise, students, they find it very hard to crack all these things, that how many first nearest neighbors are there and what is their distance. And usually they get confused because there are at least 3 of them. 3 structures are there, and for each structure you have to remember first, second, third. So total 9 or 18 quantities are there. Number of nearest neighbors and then their distance. So it will become difficult. Now let us discuss that trick. Okay. Now you have to listen to me carefully in order to understand that trick. And for that, I have made 4 unit cells, 4 simple cubic unit cells. Okay. So there will be one more atom present over here, like this one. And one more here. Now, in order to understand this logic, first of all, listen. What I'm doing is I'm assuming that when I'm considering this base unit cell, this base unit cell, which is present just in front of me. So I'm assuming that there is no cell to the right of this particular unit cell and at the bottom and at the front of this unit cell. Okay, no unit cell to the right, at the bottom, or at the front of this unit cell. Nothing is present. Okay, but there are unit cells which are present behind this one, just as I've shown this one, and at the top of this one, and of course to the left of this one. Clear? Is it clear or not?
Yes, sir.
Consider the base extreme. Consider extreme right. Okay, let me call it extreme right. Then it will be easier for you to understand. The right base unit cell. Base unit cell, or you can think about them in the terms of the rooms. This is like a building, and I'm talking about the ground floor room, which is at the right hand side, extreme right hand side of the building. Okay, here. So this is the building in which various rooms are there, and we are talking about the extreme right hand side room. And then there is no room at the front of that particular room. Of course, we are talking about the ground floor, and no basement is there, so no room will be there in the basement. And of course, because it is extreme right one, so no room to the right of this one. Okay, here. So we assume that there is no cell to the right, bottom, and front of the assumed unit cell or the unit cell under consideration. Okay, clear? Is it clear or not?
Yes, sir.
Now, can you tell me what is the contribution of this atom? This one. If there is no unit cell to the right, bottom, and front, then with how many unit cells now this particular atom is being shared? So you have to tell me the answer corresponding to this equation that I have given you, not corresponding to the general situation that we have in the crystal. Okay, what is the sharing of this particular atom?
0.
How it is 0?
What unit cell is sharing?
Yeah, only one unit cell in which it is present. It cannot be 0. So it means it is completely present within that unit cell because no other unit cell is sharing this one now or touching this one. Is it clear to all?
Yes, sir.
Yes, sir.
Because no other unit cell is sharing this one. So it means this atom, it completely belongs to the considered unit cell. Now what about this one? There are no unit cells to the right and bottom. but one is there at the back. Na? So it means it is being shared by two of them. This one and this one. So what is the contribution? Half? Half, na? Clear or not?
Yes, sir.
Now what about this one?
Four.
Very much clear from the back.
1 by 4.
So contribution will be 1 by 4. And this one? Again, very much clear from the diagram. No?
1 by 2.
One is there at the top of this also. Na? So two of them, they are sharing this one. What about this one?
1.
No, half. There will be another cell to the left of this one. Na? Cell cannot be there in the right, bottom, and front, but it can be there in the left. Na? If there is a cell on the left hand side, it will also share this one. Clear? And this one? This one again. How many?
1 by 4.
1 by 4.
Because two will be there to the left of the present two. Na? And this one?
1 by 8.
Very good. 1 by 8. This one?
1 by 4.
1 by 4. Because 2 will be there to the left of the present 2. Na? So now we are able to get the contribution of all the atoms present within the unit cell. So is it clear to all?
Yes, sir.
So if you remember these 2-3 lines that I have written, then it will be very easy for you to understand these things, that how we are getting these contributions. Now, I have to find out the first nearest neighbors, and always I will be taking this one as reference, okay? While finding the nearest neighbors. Here. Now, if you take this one as reference atom, what are the first nearest neighbors according to you? And where they are present in this particular diagram? The immediate ones. Of course, there are 3 of them. Na? Let me put number 1 within those circles or spheres, those who are the first nearest neighbors. These are the first nearest neighbors. Na? So I'm only marking the nearest neighbors within the particular unit cell. Okay? Because we are considering only one unit cell. Na? So there are 3 of them in one unit cell. Please check. And all of them, they are at a distance of A. Na? That's why they are first nearest neighbors.
Yes, sir.
Now, the contribution of each one of these is 1 by 4. Contribution of each one of these is 1 by 4. And how many atoms are there? 3 of them are there. Na? 1, 2, 3. Only 3 na? In one unit cell.
Yes, sir.
Now let me make a table for you. Nearest neighbors. Distance. Number of atoms. So first nearest neighbors. Second nearest neighbors. Third nearest neighbors. So they are at a distance A. This is very much clear. Now, there are 3 of them in one unit cell. And each one is having contribution 1 by 4. Okay. And the total number of atoms present in one unit cell, it will be 8 into 3 into 1 by 4. Please check. Because there will be 8 such corner atoms na, that we have taken as reference. So you are getting 6 na? And that's what we have studied earlier also. Why Smriti Shri? Is there any problem with it?
So I'm not feeling well, sir.
Oh, please take care. Please take care, and you should go to the doctor and take the medicine. Okay?
Yes, sir.
Okay, beta, take care.
Thank you, sir.
Is it clear to all? First one, first nearest neighbor distance and the number of atoms. This one is clear. Na?
Yes, sir.
Why I multiplied by 8? Because the contribution of the reference is 1 by 8. Na? So there will be 8 of them. Clear?
Yes, sir.
Yes, sir. This is the technique to get the nearest neighbors within one unit cell only. Just by considering the one unit cell, we can calculate all the nearest neighbors. That's why this technique is useful. Na? We need not extend the diagram to the other unit cells. Okay? That is why this is much more useful. Because we are not looking at the other unit cells. Once we have got the contribution of each atom. Now see, what are the second nearest neighbors? Now you will tell me. Just by looking at the particular unit cell that I am representing. What are the second nearest neighbors and where they are present?
Diagonal.
Diagonal one. So can I write number 2 in between them so that you are able to identify this one, and this one? And again, there are 3 of them. I'm again saying that I'm marking the atoms within one unit cell only. Okay? So don't get confused that why I'm not marking the other ones, because this one is also at the diagonal position. Okay? But that is present in the backward unit cell, na? Not within this particular unit cell. Clear? Now what is this distance according to you? This will be root 2a.
Root 2a.
It means the distance of second nearest neighbor, it will be root 2a. And what is their number? Now there are again 3 of them. And each one is having contribution half. Na? So it means there will be 12 of them. Okay?
Yes, sir.
So it has become very easy. Na? No need to cram anything. Now what about the third nearest neighbors? Third one.
Diagonal of the cube.
We are left with only one atom, and that is at the body diagonal. This one. Na? And what is this distance? Can anyone tell me?
Root 3a.
This one. Root 3a. Na? So it means it will be root 3a. And this is having contribution 1. So it will be like 8 into 1. Into 1. 8, na? Yeah?
Yes, sir.
And these are the things they ask you in the exam. So now you need not cram. What are the second nearest neighbor, third nearest neighbors, and their distances? What you have to do is just make one unit cell, and you are able to get all the answers. But you need to remember that introduction part that I've told you, that we are not considering the unit cell to the right and the bottom and at the front one. Okay? Because then you have to get the contribution. So once you have got that, then you will be there with the answer. Now clear to everyone about the simple cubic unit cell?
Yes, sir.
Now let's move towards the body centered one. Another important one. Now you will be telling me about the nearest neighbors in this particular structure, okay? By making use of the same technique. Not right now, But first of all, we will be considering the number of atoms, edge length, etc. All the things. Now, this is how we make on the paper, and this is the actual one. Okay, so I've given both the diagrams so that you are able to clearly identify. And you can see that now the atoms, they are not touching each other. There is some gap between the atoms now. Okay, so it means edge length will be greater than 2r. So this clearly signifies that if this is r, then A is going to be more than 2r. Is it clear?
Yes, sir.
Yes, sir.
They are not touching each other. Now, how many atoms are there? According to you, number of atoms. 5.
5.
How many?
2.
Because 8 are there at the corners, and they are having the similar contribution as we did in the simple cubic one. And one which is present at the body center, it completely belongs to this particular unit cell. It doesn't belong to any other unit cell. So there are 2 of them. So it means this unit cell is non-primitive, isn't it?
Yes, sir.
Because this is having 2 atoms per unit cell. And we have studied that the primitive one, they have only 1 atom per unit cell. It means the simple cubic one was primitive one. Okay. Of course, you can write over there. Therefore, this unit cell is primitive. So they may ask you about the primitive and non-primitive cells in 3D structure. So these are the examples. Now, what about the edge length? How we can get that? You can see that if I can calculate this, not this one. These are touching each other. This body centered one, this one body centered one, and this one body diagonal. They are touching along the body diagonal, isn't it? Is it clear or not? Please tell. Now, what is this angle? Let me name this diagram ABCD. Now, what is this angle ABC? Who is going to tell me?
120.
ABC. How it is 120?
90 degrees.
It's approximately 90.
What I have written at the top, kindly see. In cube, all the angles are 90. Na?
Yes.
This is 90. And what about this angle? This is also 90. Because height will be this side. This side is perpendicular to the complete base. Na? It means any line that I draw within the base, this will be perpendicular to all those lines. Na? Here?
Yes.
Yes, sir.
In right angle triangle, ABC. This is A, this is A. So AC square equal to AB square plus BC square. And this is A square plus A square, 2A square. And similarly, in right angle triangle, ACD, AD square equal to AC square plus CD square. This is 2A square plus A square again, because this is cube. So all the sides are equal. So this is 3A square. So AD equal to root 3A. Now, if this radius is R, this will be 2R. This will be again R up to this point. Okay. So total will be 4R. Na? Please check.
Considering all the atoms, the body center is also the same radius. All of them are the same radius.
Of course, same radius. This is not a void. Only then it is BCC. Na? We are not talking about the void. Otherwise, it will be simple cubic if you are considering that one as void.
Yes. Okay, sir. Got it.
It is BCC only when all the atoms they are at same radius. Okay. Or a little bit different. Of course, in ionic solids, they are going to be a little bit different depending upon whether it is cation or anion. But
So they are approximately. Okay, the expression.
no, they may be widely apart also, but they are the normal atoms. Na? They are not the voids over there. Void is something else. Void means the empty space left out by the normal atom. That is called void, or the site, interstitial site. And there will not be only one of them, because there will be many more atoms or the ions present within the unit cell. Okay. Clear?
Yes, sir.
Of course, radius of cation will always be smaller than the radius of an ion. It cannot be greater because it is having a positive charge. So it has lost some electron. So the pull of the nucleus, it will be more on rest of the electrons. That all the things you have studied in your chemistry and elementary level. So that's why the radius will be smaller. So it cannot be greater than that of the anion radius. So obviously that is going to be smaller if a cation is present. Now, AD is root 3A. And what is AD according to us? This is 4R. So A is 4R by root 3. So this is how we are able to get the edge length. Please check. Is it okay? Now, volume occupied by atoms. What is the volume occupied by atoms in the unit cell? How many atoms are there per unit cell?
2.
2. And the volume of one is 4 by 3 pi r cube. So it will be 8 by 3 pi r cube. And what is the volume of unit cell?
A cube, that is.
This is A cube again because it is cubic, and A is 4R by root 3. So this will be, cube. 64 by 3 root 3 r cube. So packing fraction. V dash by V.
Pi by A. Not by
Root 3 pi by.
3 by A.
And it will come out to be, I think, 0.68. Please check. It means 68% of the space is filled and 32% is empty. So much better than simple cubic. Na? And what is the coordination number or the number of first nearest neighbors? Coordination number. If you take the reference as this body centered atoms, then there are 8 of them, which are at the same distance from this one. All are at same distance, because that one is present in the body center. So coordination number will be 8. Okay?
Yes, sir.
Yes, sir.
Because that one is symmetrically placed because, with respect to all these atoms.
Yes, sir.
Now you have to tell me the number of first, second, and third nearest neighbors. And for your reference, I have made this diagram. So little bit change from the earlier one because this one is present now. And of course, the contribution of this one is also 1. So we need not worry about. And rest all contributions, they are already there with you. So now I will make the table and you will give me the values. Okay. So nearest neighbors. Number of atoms. First, second, third. So what are the first nearest neighbors and where they are present? Please tell me so that I can mark 1 over there.
At a distance of
Where they are present, Durga? Please tell me.
At the corner of the
Corner the-
at distance of A from the reference.
No, it's not that. What is this distance according to you? Is this more than A or less than A?
at A by root 2.
No, not A by root.
Sir, root 3 by 2.
Yes, this is root 3 by 2A. Because body diagonal was root 3A, na? And this is half of it. So this is root 3 by 2A, and this is less than A, you can see. Because root 3 is 1.73 something. Divide by 2, it will be around 0.8 something. So this is less than A. Okay? Clear? So this is the first nearest neighbor. These are the second nearest neighbors. Clear to all?
Yes, sir.
And there is only one such atom. And it completely belongs to this one. So the distance is root 3 by 2A. And it will be 8 into 1 into 1. So 8. Na? Now what about the second one? So there are 3 of them. Of course, distance is A. 3 of them. And each one is having contribution. What was the contribution? 1 by 4. Na? What about the third one? Third one. Of course, at the face diagonals. Root 2A. And again, there are 3 of them. And the distance is root 2A. So 8, 3, and their contribution is half. Na? So 12 of them. And you can verify from literature. You can verify these numbers and these values. Please check. So I have shown their distances also. So is it clear to all this technique or not?
Yes, sir.
Yes, sir.
So you are not going to get this technique in books. This is self-made. Now, moving towards the face-centered cubic structure. And I have again shown the actual unit cell and the unit cell that is generally made on the paper. So now, apart from being present at the corners, atoms are also present at the center of each face, like this. And as there are 6 faces, so 6 more atoms are there. Now, how many atoms will be there then in one unit cell?
4.
4.
4. Because now, this face atom, it is being shared by 2 unit cells. Half of this being shared by this one, and half by the unit cell which is present at the right one. Okay? Like this one. Only then this atom completely belongs to these 2 unit cells. Okay? So the contribution of each face-centered atom, it is half. So number of atoms per unit cell, n, it is equal to 8 into 1 by 8. And there are 6 phases, and each one is having sharing half. So it will be, so again, therefore this unit cell is also non-primitive. Because 4 per unit cell. Na? And what about the edge length again? Now, these 3, they are touching each other. Or you can say these 3. Along a particular face. If this is A, this is A, this is 90 degrees, this will be root 2A. Na? Please check. Okay. So in right angle triangle ABC, AC square, AB square plus BC square. You can see the actual diagram. See here. That's why I've shown the actual diagram, so that there is no confusion. So if this is R, this will be 2R, this is R. Na? Okay. So again, A is going to be greater than 2R. So AC is root 2A. So AC is root 2A and AC should also be equal to 4R. Na? Okay.
Yes, sir.
So 4R is root 2A. So R is root 2A by, or can I write A as 4R by root 2 or 2 root 2?
2R.
Now what is the volume occupied by atoms? There are 4 atoms. Na? So it will be like 4 into 4 by 3. So 16 by 3. So volume of unit cell.
Eight R cube.
No, it's not 8, 16 root 2. It's cube. Na? Packing fraction V dash by V. 16 by 3 pi R cube. 16 root 2 R cube. So pi by 3 root 2.
Yes, sir.
0.74. Okay. Most densely packed structure. 74% of the space is filled. Means only 26% is empty. What about the coordination number? Coordination number means number of first nearest neighbors. This is 12. Of course, we are going to calculate this on the next slide. So that's why I've written directly that 12. These are the number of first nearest neighbors. Now. So please note down. Clear?
Yes, sir.
Yes, sir.
Let us calculate the first, second, and third nearest neighbors. Now, what are the first nearest neighbors according to you, and where they are present?
At the base center.
At the face center, these ones, 1, 1, 1. Only 3 of them are there within 1 unit cell, which are in direct contact with this one, of course. And the distance is a by root 2. Distance is a by root 2, na? Half of the face diagonal. Now tell me their number. I'm not going to help you this time.
Eight into three into 1/2.
So you can see you are getting that answer, na? 12. Because there are 3 of them, and each one it is having contribution half. Now, what are the second nearest neighbors and where they are present? Second nearest neighbors. Try to calculate the distance. You will get to know. In the increasing of the order of the distance, they will be there. So you are taken a by root 2, and then either the atoms are,
8 into 3 into 1/4.
are the second nearest neighbors. So distance is 8. So it means 8 into 3 into 1/4. That is 6 of them. Now, what are the third nearest neighbors? You have to be careful.
3 at 8 into 8. And this 1/4.
These are the third nearest neighbors. And again, there are 3 of them.
Root 3 2/8. Root 3 by 2.
Yes, yes. They all are having contribution 1, na? Because there are no unit cells to the right, bottom, and at the front. That's why 1 contribution. So 24 cells. Can you calculate that distance actually? Or should I tell you? Yes. What is this distance equal to? A by root 2?
Yes, sir.
This is A. And now if you join these two together, this line, so then there will be a triangle called ABC. And of course, this angle is going to be 90, na? Because this edge is perpendicular to this face, na? And this diagonal is within that face. So you can use Pythagoras theorem. So AC square, AB square plus BC square, and AB is A square, BC is A by root 2 square. So AC square is A square plus A square by 2. And you can see it is 3A square by 2. And this will give you AC as 3 by 2 square root into A. Please check. So I have calculated the distance also for you. What a useful technique. And now you see if this technique would not have been present, then how difficult it would have been to remember all these numbers and distances. We are also getting the distances, na? That way. Otherwise, if we are not using this technique, then we would have made more than 1 unit cells, and then we have to look for the various atoms which are present at the same distance, and then it is very difficult. I was not comfortable with that technique at all. But once I have done this one, then I am able to tell all these distances and atoms. Clear?
Yes, sir.
Now, let us discuss some of the ionic crystal structures that are used in our daily life or important ones. First of all, NaCl structure. Sodium chloride. And the diagram has been shown for your reference. And you can see chloride ions, they are present at the corners and at the face centers. It means chloride ions, they are making their own FCC lattice. So if we remove sodium ions, it means the chloride ions, they are making their FCC. Okay? Clear or not?
Yes, sir.
Yes, sir.
And then sodium ions, they are present at the edge centers. These are called edge centers. And one more is there at the body center. Now, can you tell me how many chloride ions are there per unit cell and how many sodium ions are there per unit cell? Yes.
Chloride ions will be 4. Okay, sir.
So number of atoms per unit cell. You can give this heading, and then we can write number of chloride ions. Of course, chloride ions are present at the corners and at the face centers. So there will be 4 of them. So that's why I said that they are making their own FCC. Now, what about number of sodium ions? 12 of them are there at the edge centers, and
Yes.
every atom present at the edge center, it is having the contribution 4.
Yes, sir.
And one more is there at the body center. So again, there are 4 of them. So it means in 1 unit cell of sodium chloride, there are 4 sodium ions and 4 chloride ions. Okay?
Yes, sir.
Clear? Now, one more important thing. This is chloride ion. Let us call this as radius of chloride. And this is sodium. And radius of sodium is, these two are actually touching each other in the actual structure. And what is this distance equal to, according to you? This will be half of the edge length, A by 2. Isn't it? Because sodium is present at the edge center. Okay? So R sodium plus R chlorine, it is A by 2. Another important formula. Or you can write sodium ion and chloride ion, but that doesn't matter. R sodium ion plus R chloride ion. Now moving towards the packing fraction. So we are able to get the number of ions per unit cell, and of course the edge length also means A is twice of the sum of their radii. Now what about the packing fraction then? And of course nearest neighbors also. Let me write the number of nearest neighbors. So nearest neighbors of sodium ions are 6 chloride ions. And nearest neighbors of chloride are 6 sodium ions, vice versa. Of course, this is simply visible from the diagram. If I take this chloride as the reference, so then this number 1, 2, 3, 4, fifth one, and sixth one will be present in the adjacent cell. So the nearest neighbors are 6 for the chloride ion. Okay, clear? Clear or not?
Yes, sir.
Now, if you want to see the nearest neighbors of the sodium, then consider this one. This as the reference. This is sodium. So 1, 2, 3, 4, 5, 6. Clear? Again 6, na? Please tell.
Yes, sir.
Now, can we calculate the packing fraction? Packing fraction. How we can calculate the packing fraction? Anyone? Of the sodium chloride structure. It is actually N effective. N effective means number of atoms per unit cell. Volume of each atom. That's what we have been doing in all the other structures. And the volume of unit cell. Or you can write capital N over there. Now, what are the effective number of atoms or ions? There are 4, 4 of each type. 4 sodium are there and 4 chloride are there. So it means I need to calculate the volume of 4 sodium and 4 chloride, and then I have to add them up. Is it clear? The numerator part. Because 4 sodium and 4 chloride are there in one unit cell. And the volume of unit cell will be A cube. And what is A equal to according to you?
Sum of Ra and
Twice of sum of R sodium and R chlorine. Twice of this. So 16 by 3 pi. Effective number means number of atoms. This is the effective number that we have calculated. Means per unit cell. Number of atoms per unit cell. It is called effective number of atoms. That how many atoms are there per unit cell. This is called N effective. And there are 4 of them, 4 of each type. So that's why I have calculated the volume of 4 sodium and 4 chlorine. If you multiply this with this, it will become the volume of 4 chlorine. Clear? Ritika, clear? Beta?
Yes, sir.
So this will become 2 pi by 3 R sodium cube R chlorine cube by their whole cube. So this is the formula. Clear?
Yes, sir.
Now let us discuss about the next structure. Done, everyone noted? Have you noted this thing? Packing fraction. So this one. This is called diamond cubic. Now what kind of atoms are present in diamond? Diamond is made up of
Carbon.
carbon. Actually, these all are carbon atoms. This is also carbon, this is also carbon. They are not different. But why I have shown them to be different? The one with the black sphere and other one with the white sphere or the empty ones, because these are present at the tetrahedral sites. This is tetrahedral site. Tetrahedral means the void which is having the coordination number 4. You can clearly see that it has been joined with the 4 carbon atoms. Okay.
Yes, sir.
So all of these carbon atoms, they are present at the tetrahedral sites. So that's why, so that I can identify them easily. So I have represented them with the white sphere of the circle. Okay. Clear?
Yes.
So now can you tell me about the number of carbon atoms present per unit cell? That is N effective. Only then we can calculate the packing fraction. First of all, 8 of them are there. And then at the face centers are there. Okay. Then 4 are there at the tetrahedral sites, which completely belong to this particular unit cell. So these are 8 in number. Please check. Please check.
Yes,
Yes, sir. Yes, sir.
Now, if we have a look at the planar view, then we will come to know that actually there are 4 or rather 5 atoms touching each other along the body diagonal. Okay, 5 atoms touching each other along the body diagonal. Of course, it is difficult to show over here. Let me show you by the planar view. Suppose this is the plane. One atom is here, one at here, one at the center one, this one, this one. Now suppose these 5 are touching each other. Then this will be 2R, 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 R of this and R of this. What is this total? 8R. Yes, so it means 8R will be equal to root 3. So A will be 8R by root 3. Clear? So now we can calculate the atomic packing fraction. Isn't it? Because we are able to get the length. So please tell me about the atomic packing fraction. Now what is the coordination number? Yes. And of course, if we have a look at the tetrahedral site, so as we have discussed that the tetrahedral site, it is having the coordination number 4. So it means each carbon atom, it is being shared by 4 nearby carbon atoms. Okay, so coordination number is or the first nearest neighbor. And the first nearest neighbor distance is, it is root 3a by 4. root 3a by 4. This one, this distance, this will be root 3a by 4 along the body diagonal, because this will be root 3a by 2, half of the body diagonal, and this will again be further half of that. Okay, clear or not?
Yes,
This is along the body diagonal, only then it is equal to root 3a. But because we have picturized it from above, that's why it is appearing as the phase one. But this is not along the front face, this is along the body diagonal. Means this one, you are moving along this one, and this one, and this one, like this. Okay. Now atomic packing fraction. How to calculate? N effective into volume of each atom divided by volume of unit cell. So there are 8 of them, and because all of them they are carbon, so their radii are same. So let it be small r only. So it will be like 8 into 4 by 3 pi r cube, and A was like how much? 8 r by root 3. So it will be 8 into 8 into 8 by 3 root 3 r cube. So we are able to cancel this r cube factor first of all. 8 with 8 and 3 with 3, and then this 4 with this. So this is root 3 pi by 16. No?
yes, sir.
And please find this one. This will come out to be around 0.34 only. Only 34% is there. Please check.
Yes, sir.
Another zinc blend or zinc sulfide structure. This is exactly similar to the diamond cubic one. Just as we had one kind of carbon atoms making the FCC and other 4 carbon atoms, they were present at the tetrahedral site. So similarly, here we are having sulfur atoms making their own FCC, means these are sulfur. They are present at the corners and at the face centers, and zinc atoms, they are present at the tetrahedral sites, and there are 4 of them. 1, 2, 3, 4. Okay. So I have written over here also. So it means the situation is exactly similar to the diamond cubic one. So it means again there will be 4 atoms of each kind. Of course, 4 zinc atoms, they are clearly visible, and 4 sulfur, they will be from the FCC one. In FCC, there are 4 atoms per unit cell.
Yes, sir.
4 zinc and 4 sulfur atoms are there. Means in total there are 8, but 4 of each kind. Now what about the edge length? So earlier in case of diamond, we have written root 3a equal to 8r, but now in this case, root 3a will be equal to 4 times radius of zinc plus radius of sulfur. Okay.
Yes, sir.
So A will be like 4r zinc plus r sulfur by root 3. Clear?
Yes, sir.
Now what about the packing fraction? So everything is same. The only thing is you have to split that r carbon, 2r carbon into r zinc plus r sulfur. That's it. Half कर देंगे आप इसका. Okay. Clear?
Yes, sir.
Now calculate the packing fraction. So nearest neighbors are again 4, because it is similar to that diamond one. Means each zinc atom, it is having 4 nearest neighbor sulfur atoms, and each sulfur atom, it is having 4 nearest neighbor zinc atoms, like that. Now moving towards the atomic packing fraction or the packing fraction part. So it will be similar to that sodium chloride, then little bit similar to that, but that constant factor will be different. In that case, it was 2 pi by 3, and here it is going to be somewhat different. So N effective into volume of each atom divided by volume of unit cell. So it will be like there are 4 atoms of each kind, so it will be 4 by 3 pi, 4 by 3 pi sulfur cube by A cube. So 4 into 4 by 3 pi r zinc cube plus r sulfur cube by A was 4 by root 3 r zinc plus r sulfur whole cube. So this 3 will get cancelled with 3, 16, 4. So it will be like root 3 pi by 4 now. And the rest, everything is similar to that sodium chloride formula, isn't it? So the only thing is you have to replace 2 pi by 3 by root 3 pi by 4. That's it now. Please.
Yes, sir.
So these were the important crystal structures. Now there is one question for you. So let us see who is able to solve. Have you noted that partner? That packing fraction? Yes, everyone. Noted this one?
Yes, sir.
Then try to solve this question. So which of these unit cells they are primitive? Very good, Arun.
Sir, option C is right.
Yeah, very good. No, Prachi. Please check again. Kindly
Option C,
answer in
yes, sir.
chat box only. Don't speak better because everyone is attempting. So please answer in the chat box only. Yes, Kanaya, Vikrant. Very good. Very good, Uzma. Yes, please contribute. I want everyone to contribute. Only then you will learn. Just calculate the number of atoms. Number of atoms belonging to each of these unit cells. If the number of atoms belonging to the unit cell is 1, then that is primitive. If it is more than 1, that is not primitive. So you just have to look for the primitive ones. No? That's it. Yes, Prachi, this is correct. Correct one. Very good, Praveen. Yes. Only few students they are contributing. What about others? This is the easiest question. No, Yogita, please check again. Partially this is right, but you need to check again. Yes, Tamya, very good. Yes, Abhay, correct. I gave you the shortcut funda also. Of course, with the help of that, most of the students they are able to identify 2 of them. Now see, in 1, atoms are present at the corners only. So obviously, this one is primitive. So this one is also primitive because atoms are present at the corners only. And in 3, there are no atoms at the corners, but 1 is there, which is present in the body center. So again, the number of atoms per unit cell will be 1, because there are no additional atoms at the corners. So this one is there and it fully belongs to this particular unit cell. So again, this is primitive. And here also, this one is present here and it completely belongs to this one. So again, it is primitive. So correct option is C. And here, apart from being present at the corners, atoms are present at the edge centers, 2 of the edge centers. So it means the effective number of atoms, they will be 2, because this will be half shared with the above one. So contribution is half. So 2 will be there. Number of atoms are 2. Okay. Please check. Are you able to understand?
Yes, sir.
Okay. Now, next one. Based on the packing fraction. 2D, 2-dimensional arrangement. Hard disks of radius are they are arranged in a 2-dimensional triangular lattice. What is the fractional area occupied by the disk in the closest possible packing? Yes. Make a 2-dimensional arrangement with the help of the disk. Of course, they are the spheres in 3D, but because we are talking about 2D, so that's why they have written disks. So this kind of diagram will be there. 1, 2, 3, 4, and then this one is there, this one is there, this one is there, and again this is the closest possible close packing in 2D. Okay, clear? This type of, and this is the triangular lattice they are talking about. You can see if you join their centers, a triangle is there. So that's why he's referring to as the triangular lattice, 2D triangular lattice. So fractional area means packing fraction. There we have been calculating the fractional volume. So here they are asking about the fractional area because it is 2D case. So it means they are asking about the packing fraction and fractional area occupied. What if they ask you about the fractional area left by? It means the empty one. So then we need to subtract the occupied area from 1. Okay. Now it is very easy. What is this A equal to? This side of this triangle. And what is the name of this triangle that you are getting?
Equilateral triangle.
Yes, equilateral triangle. And each side would be equal to 2 R.
Yes, sir.
Now I think you can calculate the area of this equilateral triangle when you know the side. This diagram will be better for you. So we are talking about this particular triangle. So this is 2R, this is 2R, this is 2R. And each angle is 60 degrees. So area of unit cell. Triangle means unit cell. Na? What is the formula? Root 3 by 4 side
Root
square.
3 by 4 into 2R.
Now side is 2R. Na?
Yes, sir.
So it will become root 3 by 4, 4R square. So root 3R square. Now how many atoms are there in this triangular unit cell? Each atom it is making an angle 60 degrees. And complete atom, for complete atom to contribute, an angle of 360 is required. So the contribution per atom is 1/6 and there are 3 of them. Na? So effective number of atoms per unit cell, they will be half. 3 into 1/6. Na? Okay. So let's call this as area. So area occupied by atoms in the unit cell. This is A dash and it will be half into pi R square, na? Because these are disks of radius R. Okay. Clear? Clear or not?
Yes, sir.
So now packing fraction will be a dash by, now please check. So it will be pi by 2 root 3. Na? So what is the answer? A. Na? Because we can write it as root 3 pi by 6 na? By multiplying and dividing by root 3. Okay? Please check. Clear? Yes, everyone?
Yes, sir.
That's all for today. So tomorrow we will discuss about the Miller indices. Yeah, Tanu? What are you asking? Yes, please. Your voice is not coming at all. Please write in the chat box. Voice not coming, beta. Only fan's voice is coming. Your voice is not coming. Your voice is not coming, beta. I'm again saying, can you type in the chat box? So tomorrow we will discuss about the Miller indices and of course the problems related to this part also. Okay, beta. That's all for today. Bye bye. Take care.
Sir.
Thank you, sir.